Hello everyone, welcome to another stream. How are we all doing? Oh, I just lost my thing, damn it. Bro, what's this URL? Dashboard. TV. Right, my laptop needs to sign into Twitch again. But yeah, how's it going? So last stream, we started writing the BVH traversal code. So we've got this bound in volume hierarchy on the GPU. And there's ellipsoids on the leaf nodes, and we've tried to get them rendering, but as you can see here, it sort of gets clipped off. So it feels like the parent ellipsoid is, so this is probably a parent of this one, for instance, doesn't fully go around all of the leaf spheres. So I want to try and debug it. So yesterday I spent a bit of time off stream just trying to build something like this as a way that we can debug them. So this shows an ellipsoid being rotated, and it's just shows the ellipsoid at the normal, where the normals are, basically. Yeah. I want to redo that though, because it's using a transform rather than quaternions. And yeah. So today we're going to be making, going to be starting off by making a version which works with the data that we have in the trees, because this one works with a fill-on matrix, basically. Well, a 4x3 matrix. And I want to make sure that we do it with a quaternion position and a scale instead, because that's the way our data is shaped, or that's the format our data is inside the nodes. And if I can get it working with this debug shape, it means that our ellipsoid rendering can just borrow the knowledge that we used to get this sort of hollowed out ellipsoid rendering, right? Right, where's my Twitch password? I'm just trying to sign in on my laptop. Right, it's completely wipes everything. Right, I got passcode, but I hope everyone's doing well. 05. There we go. Okay, so I should be able to see that chat now on my laptop. For crying out loud, I don't want to upgrade the chat panel. So many cookies, no. Got it, leave me alone. Right, let me zoom in there. And destroy that panel. There we go. Right, things are in business. Okay, so let's start by re-implementing this. So we have a debug draw API, which works on CPU and GPU. So it's super handy being able to draw things at will. So I've called this thing like draw 3D ellipsoid world space, but it takes in a transform, and I want to change that to something that reflects the data inside the BVH itself. Because if we look at the BVH node, you'll notice that, so we've got the half dims, this is the radius across 3 dimensions, right? We've got the center position, and then we have rotation, which is a quaternion. It's all packed into 16 bits. So if we take this and then turn it to transform 3D, which is just a 4x3 matrix, that's going to be quite expensive already if we do that per ellipsoid, and then we've got to do the matrix multiply on top of that. So I think we're better off just decoding the data into the quaternion, just unpack it basically, and then just do some subtractions, some quaternion multiplies with a vector, and it should be good, I reckon. So I want to try and do that with this Draw 3D API here. So we need to pass in the center position in world space, obviously. We also need to pass in the half dims in world space, obviously. And then we also want to pass in the quaternion, which will say, how does it go from local to world space? That's the type of rotation it is. So world from local space rotation. Right, just to spell it out in plain English. So we're just filling up a buffer with a bunch of words. A word is a 32-bit int. So obviously as a float, we bitcast it. So we're just going to go. So, right. So the way that the debug drawing stuff works is everything's in view space. But the way that this one's got to work is, because it's this ellipsoid, is it's actually done in local space. So we get it. When we just do the ray intersection, it's done in local space. So we move everything into view space. Is that right? Good idea. No. Yeah, we'll just leave the data as it is. So I reckon what we can do. There's another one we've done this, I think. Oh yeah, like this one here. The vector one. It's kind of similar. So here's what we want to do. Center position. And then the vec is going to be half dims. Then we need to upload the quaternion as well. So we only need three of them, because you can just reconstruct the fourth one. World from local rotation, because every component, all four components add up to 1 in a quaternion. So we'll just do that. We'll just reconstruct it. So we'll save on a word at least. And that means we'll make it a little bit faster, even though it's just debug code. So that's 12 there we need to upload. Right, so we just need to change the header file. Or not just, there's still a few more things. So we need to change the header file. We need to re-implement, so that was the CPU implementation. There's also GPU implementation because we don't have pointers on GPU. So we basically have this again implemented on GPU. So we can use it in shaders. So we do an atomic add and get back an insert index, and we basically get the buffer and just write it in here the same way. So we're just going to go ahead and copy all these boys and girls, bells and whistles, and we're going to go ahead and chuck in the insert index plus, like so. Yeah, that looks good. So we've got to change this to allocate 12 words instead of 15. Delete that there. Okay, so so that's going to get all the data incorrect. We've then got to change how we do the drawing itself, the debug draw. So if we take the vector one, we're going to go ahead and decode into some proper vectors, right? So this is the half dims. We also want to decode the quaternion. So we get the rotation. So world from local rotation. So that would be 3 plus. And then obviously the W component we'll just put in as 0, but then we'll reconstruct it just down here. So world from local, and there'll just be the sum of all those things. W equals plus, yep, so that'd be Z, Y, X, and then you do one take, sum of all that, yeah? So that'll be that rotation. So the next thing to do is try and produce, wait a minute, so oh shoot. 10, 11. Excellent. So what we now need to try and do is bring the we need to bring the ray down into world space first, because the ray direction and origin is actually in view space, because that's the way this 3D render tries to work, is it just goes over per pixel the whole array that we're trying to debug draw. It's not optimized because it's just debug drawing. We're quite happy if it just runs a bit slow at the moment, but in future, if we want to render a ton of these debug draws, we'll probably tile bin it and make it more efficient. But for now, this just works fine. So it just works with stuff in view space. Really, this should be do V as VS realistically. Makes it more readable that way, you know. Right, so I've just renamed that to view space, just so things are a little bit more. So view space of ray origin is obviously 0, right? Because the ray comes from the camera, right? Which is origin of view space, right? So let's just sort that all out, right? So if we, right, so we got these out. So we're going to transform our view space, ray direction, and ray origin. So mol v for vector, mol p for position. So it adds on the translation component of the matrix. So we need to go from world from view, and then we put our view space thing on the right hand side. And then what we need to do is bring it to local space. So I tried this before. We did it in BVH ray tracer. We've got it kind of there, but it's probably a little bit incorrect. So it'll be good to do it properly here. And then that way we can bring it back to our BVH ray tracer code that we're trying to get working. So the basic idea is we've got this rotation. Now this rotation is actually going from world from local. But the way we need to do a reverse ellipsoid. Right now it's reverse sphere outline, but we need to make it ellipsoid. We'll do that in a bit. We'll do that when we get there. So what we really actually need is the inverse of this. So this is going to be the local from world rotation, and then it's just the inverse of that world from local rotation, like so. So here we can apply this rotation. Now I don't know if this logic is correct, so I probably should draw it up just so we should think about it. Yeah, let's start drawing it up. So basically, let's bring up Milton. the whiteboard. So I think this one will do here. So you got your camera. So your ray origin in world. So imagine in world space, this is origin. The camera's over here, right? And that's another position. And then the ellipsoid is here at this position, and this is its half dims, right? So you've obviously got your vector, which goes from here to there, here from there. So to translate into the local space of the object, so the object, we're just going to be doing translation and rotation. Scaling is not going to be done because that's just done in the ray trace function. So if we take if we subtract this one away from this one, is that right? Yeah, so and then it will go towards this one here. So we're saying, yeah, so we want to go towards this one from this center position here of that ellipsoid. So that's gonna get us this vector here. So then this will be the new origin like 0, 0 basically, right? And this camera position is now relative from the center of this ellipsoid. And the reason why we want that is because that's the way our ray tracing function works, is it leverages the fact that the ellipsoid is at 0, 0. And then we need to apply some level of rotation. So our ray is going to be in world space. So imagine, like, can you see that this ellipsoid is slanted? Well, the way the ray tracing function works is the ellipsoid has to be axis aligned when it's being ray traced against. So rather than moving the ellipsoid, you move everything else. Well, by everything else, I mean you move the ray instead, right? So the ray direction has to be rotated. And we're rotating I wonder if that has to be normalized again. I forget with my quaternions. But yeah, we'll see about that. It shouldn't have to be if it's already normalized, I think. Yeah, as long as they're both normalized, I think it's fine. But yeah, so we rotate this. So we've got this direction. So imagine if you've got this ray, which is going, and you've got this direction. So what you need to do is you need to rotate it around. So the rotation at the moment, imagine if axis aligned, it would be like that, where it's like this instead, right? Where it's on its side like that. So it's moved that way, but that's the world from local rotation. But what we actually need to do is move it back this way. So we've inverted the quaternion, and now we're applying this to the ray direction. So it's moving, so the ray direction should now be launching kind of like that. Right, someone else. And then we need to move so that's the direction. Now the position also needs to be moved. So the position, wait, is that right? Yeah. So the position then needs to be moved down here. So when it's like axis aligned, it will still hit the same point, basically, if you will. So we need to move local from world, and now this vector, to here to this position is going to be centered around here. So it's going to rotate around the object. So hopefully, I think that should be all right. So we'll end up going here instead of the camera. The ray direction will go off there or something. I don't know. I'm a bit off with the drawings, but it'll go here instead. To your new axis aligned version. Hey, the Jod, how are you doing? Welcome to the stream, sir. What have you been up to? So I think, yeah, we're applying that rotation to this. It's a bit much. Yeah. So that ray, oh my days. So rather than being there, that ray will be rotated by to about there. And that'll be the new position for the camera. And then it should still hit the same place on the ellipsoid as if the ellipsoid was rotated as well, right? Okay. So I hope that makes sense. I think that makes sense, but let's plug it in and see how it goes. So this is our new local space stuff. So I went and did this as a sphere, but we should really bring it back as an ellipsoid. Not gonna lie. Because I did a whole transform, so it would have like descaled it back to a unit sphere. So a sphere with a radius of 1. Ooh, yeah. But let's go ahead and make it back an ellipsoid. So it also needs to have passed in half dims. And this sort of thickness is like the outline thickness. So it's just a cheap way of doing, well, if we remember, this is how the current version looks. It's just using the normal and just saying, well, if the normal is 0 on one dimension or near 0 on one dimension, then it's a successful hit. If not, you know. So obviously we could do it better if we just did like a capsule that was sort of bent. But I didn't want to do that right away because it'd probably be a lot more work. This was just a lot easier to do, and it should just do the job for debug purposes. And if I need something nicer for like the editor, because as you see, if we look at this down here, it kind of disappears. So it isn't that nice, but it's good enough to be able to see a tree of ellipsoids. So yeah, we'll change this function in the future to be something better. So here's our reverse ellipsoid function. We're just gonna bring us back into all right. And then right, so I've heavily modified this so it does that if it's, and it gets the start and the end of hits. Because when you ray trace against the ellipsoid, you get where you hit it at the front and the back, which is quite nice. So we can leverage that and get the 2 hit points and see if any of the 2 normals are 0, basically, or near 0. And then those will be hits or no hit. Okay. So we plug in the the half dims of the object, right? Nice. And that now we need to so this will be in the local space of the object, so we need to undo the hit pos. But really what we would probably want to do is just say, let's just class anything as a hit. And we'll come back if this works, and then undo the local space, but then put it into view space, and then do if it's the closest hit. because we won't, right now we don't have multiple objects. I don't have a hit. Shoot. Yeah. So right now we're just concerned about the color. Perhaps going on here. Oh, I didn't say quad. Alright. What is this? Because that's a GFX global. What? What's going on here? No center position, wall space. Ooh. Rightio. Okay, so now we've just got to change the function we're calling CPU side. Again, this will come up GPU side as well, which is super nice. So we want to get the position in there, so that'll just be a... Let's just put it at 0, 0, for, you know, right in the middle for now. We can test the translation in a bit. The scale, I guess I can do that 3, 4, 5 thing again. And then the quaternion will just be ROT, right, rotation. Right. So hopefully this works with this new parameters. Right, so obviously the rotation is a bit buggered now. We did break that. It kind of like really messes up the... Yeah, it messes up when it rotates. So that's obviously to do with... Remember, we're not rotating the ellipsoid. We're rotating the camera to put it such that the ellipsoid is axis aligned again. So I think what we need to do is we need to take those camera things and render this ray direction and see what's going on. So if we draw it all in local space, but we'll put it in world space, right? So we'll bring it all into what local space would be, but then put it in world space. We can see it behaving within the world and see what's going on with... Yeah, I think that'd be pretty cool. So what we'd probably want to do is render... So first of all, we render the... Alright, so we should really get them all in here as little variables, right? Because then... let's bring that back. So center position is just going to be this for now. Center pos. Then we'll do like a half dims. And then we'll do like then there's rotation. So the idea is we need to create another one which will bring it into local space. And how do we achieve that? Well, it's quite simple. You just no translation, no rotation, and you just have half dimensions. So that will be in the local space of the object at this point. So then what we want to do is simulate the ray stuff. All right, how do we do that? So we need... How do we do this? Sweet, so we've already got that there, innit? Yeah, so we need that. So we'll do another inverse thingy here, right? And we'll get that. So transform 3D world from view. So we need that. We also need the we need to make up array direction. Just make one up. We'll just do redirection of view space. Then obviously the origin of view space is just 0. So what can be a made up direction in a bit? What's that? What's the logic again to do it? So I want to make sure we've got something that we can visualize. Redirection for UV, so you're taking the field of view, which is like 90. And then a UV pixel. Maybe we just copy this quickly to CPU side and just plug in the variables we want, right? Alright, I think that'll do. So view from where's our view from world? Here we go. So we plug this in, and we're just gonna say, right, so the field of view is just 90. And we're gonna go ahead and gonna produce some sort of screen dimensions. Hey, virus stick. How you been? It's been a little bit. What have you been up to? How's it going? Yeah, it's good, man. I'm doing good. Went on a nice walk when I got back from my parents with my wife and the baby. We took him to the park and put him on the swing. Yeah, it's doing good. So had mostly a relaxing weekend basically because had a lot of busy weekends, so we had a nice chill one this week. But yeah, doing good. How about you? What have you been up to? Is this, yeah, temps. We still haven't got a resizable screen, but this is the way. Who needs a resizable screen? Then coordinate would be pixel coordinate, so that would be, let's just whack it in the middle. Should we whack in the middle? Alright, so I'll generate, wants to float, does it? Alright, so it generates the redirection view space, and we're going to go ahead and translate that into world space from view, and then translate that from, that's rotten it. Right, so then that produces the local space. Excellent. So what we should be able to do now is use our debug draw API to debug draw a sphere, which represents a point, and we'll draw it in world space, but we'll draw the local space one in world space, so we're just viewing it. So ray origin world space, and the size of it is just going to be 0. Or it could just be 1. And then you don't need any of that. Color, and then don't Z test. Sweet. Now the other one we want to draw is a vector. You know, maybe we should draw this as a 2 or something. Or maybe 3. I don't even know anymore. Something like that. Then what you also need to do is draw. So this should react live to when we move the camera, but we'll see it in the center of the world. And then we also want to draw the vector as well in world space. Yes. From the position of the camera in the direction. Wait, no. Local space. Sorry, I kept saying local space and I said world space with these things. Right, what else? I think that's it, isn't it? Thickness, color, yeah. Right, so this should help us figure out like what the problem is with this drawing code. Right, so there's our camera rotating around, and it just goes really far out there. The problem is it responds to the camera, so it comes up as high as I am. Then it goes into my face. So it looks like the direction is pointing that way. There's a little tip. I need to disable that. Drawing the nodes for a minute because it does get in the way a bit, not gonna lie. But yeah, I don't know what we should do. Should we just keep the... Yeah, we'll keep it. Let's make it a bit bigger though. Let's multiply this vector so it becomes a bit longer. Let's scale it by 4, and we can give it a bit of a different color. I don't know how. Well, we'll just hard code it, right? We'll just give it like something like that. 2, 3, 4. There we go. I'm currently working on a community project. Finally got back to doing it. Doing a little programming. Sweet. Just got another job interview now on Wednesday. So things are pretty good. Awesome. What's the title of the job? Just wrote a very satisfying 2-liner to add to the entry. To add a new entry onto the link list. Onto a link list. Cool. Is it like a doubly linked list or a singly linked list? Very cool. Van driver, nice. You like delivering packages, I guess, or something. And what's your project you're working on? Awesome. Yeah, they're a bit easier than the you know, them pointing back. But you often need the one to point back. Right, so here's our camera. It's orbiting around this ellipsoid. And obviously, as I move up, the camera moves up too. Trying to figure out what's going on. Trying to think if the... See, that's a miss. Oh yeah, but obviously it's wherever I'm aiming, isn't it? So wherever the center of my camera aims, it aims. So that seems to orbit okay. How's it changing the speed of the... Why not draw in the other one? Here's the other one. We could draw a bit further away maybe. Or maybe we can if it like that or something. So when this one rotates, it does that. So We reconstruct that, okay, right? It's the sum of that. The quad. Let's just double check we're uploading right. 789, yep, are the rotation. So we transform the ray direction from view space and the origin from view space into world space. We invert the translation. See, I don't think that's the problem, right? Because if I just do this, I'm pretty sure it's go the other way around. Yeah, it's just span the other way around. Something like that. But it still stretches. Then this one is, we multiply a vector. See, it must be something to do with this set of functions here. But it looks okay when I draw it out, right? What am I drawing out? I'm applying that same logic here. Do I need to descale? Do I need to descale the ray direction or whatever? Seems, I don't think you do. You see, I think we should fix that. We should fix the Y so it never goes up any higher or something. Because when I'm moving, I want to be able to see. Are you still traversing the BVH? You should write a program to do it for you instead. It will be faster. To write a program to do it for you instead. What do you mean, meatball? Yeah, we're trying to figure out why. We're trying to write a debug function. Yeah, we're trying to write a debug drawing code. Because my tree, as you can tell, is clipping. The ellipsoids are not being made correct up the parent hierarchy. So they're clipping. So I'm trying to build an outline ellipsoid that we can just use quickly to find the problem. Or confirm the problem. It'll also be useful as well in other cases. The list is a queue of operations. So as a SLL works fine. Right. Oh, singly linked list, yeah. The project I'm working on is basically a desktop pet, but before I joined, there had been more drama than work. Oh. Oh, so you're working in a little team. Nice. How many people? Right, so save it. Don't just joke about your stream title as if you're doing actual BVH traversal. Oh yeah, by hand, yeah. No, yeah, you do it. Yeah, you have to do it by hand to figure out how to write one, right? But yeah, it'll be way faster. Highly parallel. How you been, Meeple One? What you been up to? See, if I'm locking the, I also need to lock the Y of the what? There's a translation going on in there. Oh, there's a translation in the world from view. Should I just screw this world from view thing? Let's just say it fires forward. So let's just say, rather than any of that, let's just delete this thing that we brought in, because I don't want to leave, I don't want to create mess in my project anymore. Because we've done all the research, I think. So I think what we'd like to do is just say, well, it's just going to look forward. Then this is going to be probably back by -5. And then there'll be the rotation. And then we can apply that. So this should hopefully now not be dependent on how my view moves around. So we can see, just analyze the actual object as it moves around the local space ellipsoid. Alright, so that's obviously not far enough away. So let's do 10. Right, so you got the camera which is orbiting the ellipsoid, which is supposed to... The ellipsoid is meant to be rotating, but the camera's rotating instead. And it always spins. The ellipsoid spins and shrinks and grows and things, but what we're seeing is that the direction
Hey, Tap. How's it going? Thank you so much for race time. How did the stream go?
There's a couple of us, but I'm the only programmer. There's a few artists as well and whatnot. There are 2 of the programmers, project leads. That's what the drama was. And I guess I'm also a product lead. Cool. I had the role on Discord. Yeah. Awesome. That's right. To me, I don't know what to tell you. Yeah, I know, but when we run the code, it doesn't look right. I don't know what it did. Yeah, that's what I was thinking it could be, but I don't think it is. It's a bit strange. I need to have something else in this debug analyzation, because it's not quite giving me a definitive answer. I need to add more. So right now it's just doing this. This is what it's doing. So I think the... Yeah, we need to have another thing, another sphere being rendered, I reckon. So we're moving the camera such that the ellipsoid is axis aligned at 0, 0 origin as well. So in the local space, the objects of the ray and the camera move. But looks like that. Maybe we should get it twisting at the same time. Maybe that's going to help us. What's the BVH? Bounding volume hierarchy. So basically, if I enable this other thingy, we've built a quad tree not a physics quad tree that you typically see in 2D, but a tree with potential of 4 leaf nodes. So effectively this has an ellipsoid. You typically use like an axis line bounding box with an ellipsoids all the way down for reasons. But the idea is this builds a bounding box which covers all of the descendants. So the leaf nodes are the ones that we render, so each of these is an ellipsoid. And so this parent has an ellipsoid which covers all of these guys. So when we ray trace, rather than testing all the leaf nodes, we go down the tree and only test the ones that we hit and ignore the rest of them. So the more complicated the tree is, the more savings you'll get, basically. Or the hope. Obviously, it all depends locally where all the complexity is. If you have a lot of complexity in one space and your pixel just goes there, or you're going to have to deal with that complexity and ray trace against it all. But yeah, it should hopefully, well, it does, it reduces the complexity of the, it reduces the number of rays you have to test against when ray tracing a whole scene of objects. So that's a bounding volume hierarchy. They're used on GPUs for ray tracing and offline ray tracers as well, and they're used in physics engines as well, I think. But they're kind of got different requirements in physics to rendering. I think rendering requires a better built BVH, because you can spend some time constructing a real nice one, because you're impacted on the traversal time. Whereas in a physics engine, if you have a BVH, you need to build a new one every frame. So you kind of have that trade-off between how long it takes to build the BVH and how much saving you're going to get with it. So the build time is included in that calculation. No worries. Is the thing where you subdivide the volume into halves recursively, so you can quick calculation. It's not necessarily halves, but yeah, it's not halves. The bit that's good about the bounding volume hierarchy is if you have an object over this part of the screen, an object over that part of the screen, the bounding boxes will only be around those objects. So the things that miss those objects won't even traverse into their children, which is a nice feature about it. Okay, that's cool. Major drawback, it requires static geometry, yes. Not necessarily, yeah, with dynamic geometry you have to refit it. They call it update in some of the APIs, but it's really terrible word, because update means anything. It's such a general word. So the other word they use is refit. So what refitting does is you move your objects around in the scene. And refit, you start off at the leaf nodes and you just traverse up the trees and you reconstruct the parents' bounding volume around all the children where they've moved. The downside to this is that you won't get an optimized BVH. So if I can draw it, it will be better. So say if you have like, for crying out loud, got a couple of balls here, right? There's your bounding box around it, right? Technically it'll be tighter, but there you go. If I move them around, my bounding box has now changed to this. But also I could have got some objects from another, this was another sibling one, has now just moved into mine, if you will. And you start getting a very unoptimized tree like this. Whereas if you rebuilt it, you'll get a better constructed one where maybe you do stuff like this, right? And then therefore you got more empty space, and yeah. But obviously rebuilding a full BVH is expensive, so you just refit it instead. Now the great thing about refitting is if the objects return back to where they were, then the tree is back to being optimized again. So if your mesh animates wherever your mesh is, or the closer it is to that resting pose, the better it is for the performance, right? But the wider it moves away from that resting pose, the more likely it's gonna get an unoptimized shape. That's the basic idea with refitting and animated objects. Hey Buffer Overflow, how you doing? The more heavy the rendering is, the better trade-off is, yes. I guess so. I am not quite sure about it though. I would like to say, obviously if you don't have a lot of objects in the scene, the BVH isn't going to be beneficial. But yeah, there's a certain point where the BVH just becomes far much better. And then, because obviously if you just have like 32 objects, you don't need a BVH. But when you have like, probably, I don't know the number, but there's a number, then the BVH become beneficial. I'm not sure if it becomes better. I'm not sure what the curve looks like, right? But I'm sure I'm not quite sure on it. But yeah, there's probably a great benefit for a good while. But as you might get to such a large tree, it might be... Yeah, it might still be... Yeah, it's still... Yeah. If the number of objects is always a problem, you always want to keep that as low as possible. There's different techniques you can do as well. Yeah. Because the refit has the same cost whether you do pre-rendering or rough rendering. What do you mean by the refit has the same cost? Yeah, you're limited to a set number of BVHs that you can refit. And then you have yeah. And typically you build like 1 or 2 BVHs in a frame. Yeah, this is bananas. So what can I do to debug this? So we're rotating the camera around the object instead of the object. And we're getting this silliness. It's not the quaternion being the wrong way. And if we run the debug view, where are you? So this is the debug view we've built where we put the object in local space, just have dimensions on it, and we render a sphere that rotates around the object with a vector that points in a certain way. And it appears like, so I feel like we need another, we either need to rotate the object with the, no, because if I rotate the object I can't see it working because my code doesn't work. So it seems to orbit fine. Why'd it go? What else could we rotate? Could we rotate another sphere that helps out? Let's figure out the problem. Like we're rotating a banana. So you got so you're rotating the camera around the object, and the object, it's as if the object is not maybe I'm rotating the camera I can't be rotating it the wrong way around. Could it be the act? Right, let's review it again. Right, so here's the one with the bug. So if I imagine I'm moving the camera around, how is it causing it to stretch and shrink? So it means that all of the pixels which have a direction are obviously not uniformly. It must be something to do with that. Like, yeah. So if it's causing them to rotate the camera, is it the direction? It would always be the only thing that's different per pixel is the direction. So, but then it's also spinning and going in. The matrix operations for world view model are all pain, aren't they? Yeah, it's definitely one of those things you have to keep doing, because it's quite easy to forget things. But yeah, how I avoid confusion with the local world and view space stuff is you just name stuff properly. Local from world, and then obviously your world just goes on the right hand side, and then out on the left hand side it produces the local, right? And you can do this for matrix multiplications of two matrices and things. It's a good naming system. But I think I still get confused on if I have a couple of rotations and then I have like a scale and then a translation. How do I combine that to produce the local space from world thing? It's a bit fiddly still in my mind. But yeah, this is pretty flawless, this system. When it comes to a fill-on matrix that's been constructed, how do you combine them and know which one you have? So like if I didn't rotate the direction, you're just going to get this thing that comes and goes into existence, right? Because it's just going to keep looking in one way. We could just try that quick, just to prove that is the way it works. Did it just not change anything? Oh, wait, sorry. I didn't change the shader code, I changed the... Alright. Alright, so instead you're getting an orbiting... I don't know what's going on here. Ooh. Right, so that kind of goes around in this weird curve. Obviously it moves with the camera actually, doesn't it? And then... Oh, you confuse the shaded GPU code. That's cool. Don't matter. Hey Sockham, how you doing? Many more benefits. We can share CPU and GPU code. It's amazing. Struts and functions. This is the way. Could it be something as silly as normalizing? See, if it works CPU side, have I just buggered moving it to GPU somehow? You know what I mean? Is it my... Yeah, they're all floats, right? So let's make sure we're getting these right. So the center position that comes in. Yes, so we convert to, it says E32 from a float. Seems alright. Seems alright. Yup. Convert them into a float. Legit. Got enough bits in there. Yeah, so we're getting the right. You know, maybe this is a bit of, you know what? Let's translate the next. Rather than trying to save the bit of memory, right? Let's just do 13 of them. Right, let's just see what happens. W. So I'll change the GPU one in a bit, but see if that works. For crying out loud, that was the problem. It works now. So it must have been not a normalized quaternion or something. I gotta figure out what the crap is going on. If it all adds up to 1, and obviously W is 1 take. So, right, well I'm glad we found the problem. This is good. So let's try and save that piece of memory. Let's see what the crap is going on. So, alright, so what is going on? So, hang on a minute. So, let's try and visualize what's going on here. So let's produce another one, a rot. So this rotation is equal to rotation, but I'm going to go ahead and say W is equal to X plus Y plus Z. And then I'm going to do like a 1 take. Yeah, it's the new age. This is the way. People need to copy me more. I did it so people could steal my idea. But no one's stealing my idea. And it's annoying. I want every programming language to be like, you know, stealing my idea. Because we shouldn't be living in the Stone Age where we have one shader per file. We shouldn't be living in the Stone Age where we have to translate our complicated. We have to write our structures in some intermediate formats so we can generate it in two different languages, like a shader language one and a or hand maintain two different structures. You know, what other things? We should have first class bindless support, right? We should have to be passing indices around and manually indexing them in some array somewhere. What else? So many good things, right? Oh yeah, and programming in the same language with the exact same semantics. No GLSL and C because they're kind of similar. They're not. They're completely different. GLSL doesn't even have enum support in 2024. Enums. You don't have them in GLSL. Bananas. That's prehistoric. But hey Sockham, how's it going? It's been a while. What have you been up to? So I want to whack in a core breakpoint, programmatic breakpoints. You guys should put these in your code base. They're amazing. So you put if statements in and programmatically break on stuff. It's just built-in debug trap in Linux. And on Windows, you've got underscore debug break. They're legit. You can also do it with assembly as well, but that's cross-platform. And then when you open up in your debugger, voila, breaks. So, let's look at AROT. Now let's look at ROT. It's on the first frame. First frame ain't the problem. You know what? Debug breaks are not the breaks are not the answer here. So we'll just write it and AROT it. Maybe we just have to say W's actually. ROT W F, and then we'll say AROT W F. So let's just compare them. And that's all I want to see. And I can't believe that was the problem. But it's good though because we do this compression technique in the we do this compression technique inside the tree that we're building as well. So as you can tell here, these are way off. That's not good. So what happens if I were to normalize this norm quad? Does that help? And if not, I've got something completely wrong because I could swear you reconstruct. It's a technique you can do, reconstruct a quaternion from 3 things. No, it's still a bit buggered. Right, I must be thinking about something. Quaternion, all components add up to 1. Is that right? I'm sure I'm going to get told by someone who's really good at maths in a minute. And there'll be like 5 people who show up. Sorry for the blinding white screen. I don't know what's happening. Huh? Is something happening with the audio? Like half the samples are missing. Is it still going on? Is it my microphone or is it the Oh sweet, thank you. Right, I don't know, maybe I was talking a bit quiet, I don't know. But yeah, search Thank you there, Jay. Thank you. Thank you there, Jay. Nice. He was very nice there, thank you. You're not rude. I have evidence otherwise. Turn on the dark mode. Oh, like a loose connection. Right. Maybe it could have been the microphone here. In mathematical field of representation theory, a quaternionic representation is represented on a complex vector space V with the invariant quaternionic structure an antilinear equivalent map J V to V, which satisfies J squared. Oh, could it have been square and a square root in that I'm missing? That is kind of triggering some kind of memory. But anyway, this is blowing my brains out. I probably have to... You know, maybe if I just followed this stuff. Ooh, what's this say? Is an axiomatic system that abstracts the concepts of quaternion algebra over a field. And I've got 4 parameters here. Hey Deba, hey, how's it going? Hey. I started. Okay, no. So does anyone know about quaternions? And how do you reconstruct the W if you just have the X, Y, Z? Is anyone of that knowledge? Right, maybe I need a square it or something. So I just finished C++ until OOP, but the thing is, I like C# a lot, and I wanted to learn it more to practice with it. Is it bad to switch, or should I stick to only one language until I master it? So what do you want to do? Like, what's your ultimate goal with programming? Like, what things do you want to make? What are you trying to do? Because you should pick a language to develop in specifically for things you want to do, right? Do you want to do more low-level programming? Do you want to do, or do you want to, or do you want to learn how computers work? Or what are you trying to achieve with said goal of switching to C++ from C#? Yeah. C++ is a very complicated language. So I think where I learned about this quantization thing, is from watching a networking thing, and someone compressed a quaternion down, and that's where I learned the trick. But I never used it. I think so I've just tried to use it. You take the smallest of the 3. That might be it. That's what I'm probably misremembering. All right, here we go. Right, let's skim read this until we find our answer. So it might be this here. One existing method of quantization is called smallest 3. It's exactly what it says. Determine the component with the maximum magnitude. Note on which it is, then store the other 3 components negated if the largest is negative. This sideline information requires 2 bits of storage. Yep. Oh damn, I need to find 2 more bits. For whatever it's worth, we can think of this geometrically as performing one of 4 isoclinic rotations by 1, x, y, and z. The shape generated by this mapping in our case is of a ball of radius square root of 2 divided by 2 when the scalar is the largest component multiplied by that thing there. I don't know what's going on. I think I'm misunderstanding the context of this article, but this is the knowledge I would wish to acquire. So I think that's what I'm missing. Oh, what is this? So inverse square root, so like reciprocal square root, 1 plus that gets you an s. And then you're doing, yeah, but what is this? Because this could maybe work. I don't know what the range of that would be though. I might scale it up. These are pretty, and it does require a square root to decode it. Hey Glorious Sir, how you doing? So you want to switch to C sharp. Wait, and after finishing basic on C++, I feel like it's still hell for me, so I want to switch to C sharp. So, the baby. What I would like to say is C++ is very complicated, so when you learn it, you might be like, well, there's so much stuff here to learn. So if you're looking into low-level programming and you want to at least learn more of that, obviously you might just want to go and work in C sharp. If you want to work in C sharp, just go and work in C sharp, and but if you wanted to sort of learn more about the C side of things, I recommend you pick up Raylib. Like if you're gonna make a game, this is because I'm sure you're here because people are making games or whatever, right? Because we're making games here. Try Raylib out and try with C, and just learn C programming, right? And just get and learn that side of things because it's a smaller subset of C++ and it has some differences as well. But that's what we program in here, or I program in, whatever you say it. And I find that it's a lot easier to work in as a beginner and as an expert. The language just gets out of your way and the problems become, you solve the programming problems and you fight the language less. So if you want to, anyway, there's plenty of examples on here on using Raylib. The reason why I suggest using Raylib is because it's a nice C library which allows you to write a small amount of code and get stuff up on the screen. So when you're learning the language, you can just do things in it easily. And there's plenty of code here to copy from. Obviously start simple, but as you go up. But that's what I would suggest. Oh, it's back crackly, damn it. I hope you heard all that. What I'm going to do is unplug things and plug things back in, because that usually works. Computers, right? So I'm kind of here, but I'm coming through a different, because Linux, and now I'm here, and it'd be echoey because Linux. And if I do this, and even press the cancel button, you realize it still works. What the crap is this? Why can't I hear anything? My face. Wait, it's not even plugged in? Oh. Right, now I can hear myself. This is good. What's going on? I'm still here, I promise. Right. And bingo. Now let's just sort my face out. Back. Right. Is that good? Right. Let me know if that gets crackling again. But I've also moved my cable. I think another part of the problem could have been that the cable was actually resting on the sound card as well, or the sound device as well. So I've moved that, so there's probably no interference happening there. I can hear it back here though, which is strange. So usually I can hear everything. Oh, for Christ. Damn it. Oh, wait, things are still okay? That's not okay. Damn Linux. Right. It's hopefully not. Right, let's get back to this quantization thingamajig. Love me a good thingamajig. Oh. Okay, that's cool. Right, so we could do this thing. We could work this out. That's interesting. So I think when I was looking into network, programming, I think there was that Glenn guy, you know he is that Glenn guy. Networking for physics programmers. That GDC talk, you know. Yeah, Glenn. Gaffer. Anyway, there's a talk at GDC which you have to look around for. It's a really good talk. I really recommend it. I think his assumptions that networking was. Oh, okay. Don't know why I nudged there. I need to get a new hub. Yes. Another USB hub. But yeah, I think his assumption where he said that networking infrastructure would get cheaper, or network traffic, or network transfer would get cheaper, or something like that, it ended up being wrong, I think. So so if you're gonna watch this and go along with his suggestion, because in the future it will be cheaper, I think his suggestion will end up being quite expensive. I think people these days say Anyway, I'm not a professional. I won't bother speaking about it much more. But anyway, in here he talks about quantization of, and this is slow. There's a, you can watch it on YouTube, right? It's right here, isn't it? Oh wait, there's a first one. No, 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 no. Or at least watch it on GDC's website, right? I watched it on YouTube ages ago, or was it on? No, but he also has his articles as well. It could be on there. Wait, he talked about quantizing quaternion. I think it was with that smallest 3 rule. He's got a lot of stuff on here though. Yeah, that's one to read. I think float point determinism. I think I might want to look into that later. Serialization strategies. Here we go. It might be in here. What? Quaternions. Here we go. Uh. Yeah, so I could serialize all 4, but I want to save. I guess I'll be saving 6 bits because I need 2 bits to tell the component if it is if it is true. I don't know if it's got it in there with a quaternion. Yeah, I think it's just sending the whole thing over the wire in this. But he mentioned it in the video. Maybe he's not got it on his blog. Right, see if we can find it on YouTube. No, it's on YouTube. It's really annoying. Let's go on GDC's website. There'll be a better feed for it. Oh my days. No. Game Developers Conference. Yeah, this thing. Thing is, it's not really Google, so I don't know how good this search bar is. Oh, physics for gameplay programmers? Oh, maybe that was it. Maybe that's why I couldn't find it. Oh, no, networking for physics. Yeah, this is it. This is the video one as well. Right, we can finally find it. This will be a good feed. Delta smallest 3. Right to it. This is it. He's a really good he's really good at presenting as well. Right, I cannot hear a thing. Oh, he's just really quiet. It's right, I'll translate. I'll turn it up for me. I'll just translate it. Yeah, it's unmuted. I've got it up max as well. Let's turn up the volume a bit, I guess. So minus 26 decibels. So he's using delta because he's sending over the network. He knows the previous one, or a shared previous one. But he mentions that smallest 3 trick as well. Right, so he must have mentioned the smallest 3 trick earlier. Here we go. Yeah. Right. Wait, let me hear that again. Right, so the magnitude adds up, of all the components, adds up to 1. So, yeah, if you square... If you square all the components... So the way you get magnitude typically is you do the dot product with itself, square root it. But this is talking about just doing the dot product with itself. Adds up to 1. Right, but this is where you can, so if you square these boys, right, this is the answer, here we go. So we can roll with that. We need a square root though to reconstruct it, but that's alright. So, let's get in there. Yeah, so you just square root it, apparently. Because we'll need that trick in the, because we pack them. Right, that still hasn't worked. It doesn't keep the sign or some, there's something odd about, no, it still fails. Oh, I got to square them, sorry. I didn't square them. So, oh, then minus, whoops, sorry. So we square each of them, sub them. So I could say square it. I've not got a sub thing. Yeah. That's alright. I have like a sum elements, but I don't have a subtract elements, which is cool. So we'll just do it manually like this. So it does take a bit of... I don't have a square. Is it a square? Right, I don't have a square for Okay. But it's useful. Right, let's just do it manually. And right. So we could build that. There we. Oh no, it bounced back the other way. Something's still off. But that's cool. It's getting there. It's not stretching. It's definitely close. He says positive though, right? So it's saying. Is he saying absolute? So I think is. So we can just make that into a function, then reconstruct W. No. All right. Drop the largest by absolute value. What does that mean? Right. Yeah, we'll lose the sign. Maybe. I should bring this into CPU land. Oh, so you're saying you'll lose the sign when you reconstruct it like that, so there's no way to keep it? Because you'd get an incorrect rotation if it doesn't keep carrying on going around. So we can't do that. He must like it must be there must be a correct way to do it though. Yeah, you lose the sign. So watch as it approaches 0 down here. They both like this one keeps going and that one just bounces back up. Yeah, so we lost the sign. Oh yeah, obviously I did ABS it, didn't I? So hang on a minute. Let's not do that. But I don't know what that plus and the underscore was. I treat that as an absolute. But yeah, it still bounces anyway. What is it? He probably means copy the sign back over. But what is that sort of plus with an underscore? What does that mean? I didn't do maths. Meaning multiple meanings. Amazing. In maths, it indicates the choice of exactly two possible values. One which is obtained through addition and the other through subtraction. Right. Replaced by either a plus or minus sign, following the formula to represent two values or two equations. Right, so I think you've got to remember the bit, basically. You've got to remember the signiness, perhaps. I think you can reconstruct the quaternion to a version where the sign is positive, then quantize. And then quantize. Right. I did go and normalize it there. I didn't need that normalization. That's silly, but right. He did say words I didn't understand. I don't know if you understand these words, glorious sir. But he says you got to drop the. No, here. Drop the largest of the components by absolute value. If not, you have numerical precision issues. What does that mean? Right. Can I see it in this? Can I see the code in this thing here? No, this article doesn't have it. It's got some interesting tricks though, but yeah, we'll need a square root regardless, so maybe we can use one of these. Yeah, maybe it is ignore the sign. But then you wouldn't get a quaternion that adds up to 1. Maybe. I don't think that sounds correct. Uh... Construct, for example, 24... no. He's talking about a situation where one component dominates the other. So if you drop it, then you quantize other without loss of precision. Then you get a missing component. So it's variable component encoding. I'm not sure what dominates all the time. Right. Yeah, we just do a flat 8 bits per component. By dropping the largest one. Right. So yes, you don't always drop W, you drop the biggest. Oh, right, I see now. Right, so it's saying get rid of the biggest vat. Yeah, but I'm doing like... Maybe I see. But if you encode in fixed point anyway, the largest doesn't matter. Maybe? Right, I think I understand it now. Okay, so we can fix the sign problem just by having an extra bit. That's not an issue. But yeah, I got some ideas. So I think we can move on from. Wait, you need 2 bits to encode. Which one you dropped? Yes, you do. Unless you always do W, and yeah, we'll see how it ends up. I think I'll just try dropping W for now, but and see what the problem is when I have it in the game or in the when I have it working. Dominates means contributes to the magnitude the most. Right. Right. That's cool, Maple One. You have a good rest, and I hope you have a good start to your work week, my friend. Thank you for popping by. It's good to see you. Get a good sleep. Sleep is good. But yeah, I think this is good. Right. So now we know when we try and test rotation, we've got to probably change it a bit. But when it comes to this debug draw API, we'll just package the full quaternion because it's debug drawing code, right? But we know the problem when it comes to packing now. That's really cool. Right, so now we can actually test. Wait, let's turn this back down because I don't want to blast your earballs out with Stone Rebel, even though but my earballs did. So yeah, if you guys haven't watched this video and done a bunch of squats while watching it, you should do so because it is amazing. I really want to do some programming, I really want to like create a multiplayer experience with this game. It'll be sometime in the future we'll do some of this sort of programming. But until then, goodbye, Glenn. Right, so that was cool. So let's finish off this. So we should be able to get rid of all this and just draw a lovely rotating ellipsoid. When we get the lovely rotating ellipsoid in there, we can then debug. We can just do this on GPU and it'll be amazing. We'll be able to see exactly what's wrong with the construction of the BVH and the parents not being big enough, and therefore fix it. And it'll be legit. Oh, for crying out loud. W. Rightio, so when we get the ellipsoid, 10, 11, 12. So we run that, we should have an outlined ellipsoid now in our very hacky way, and it should just rotate, no biggie, with quaternions and center position and a half dims. Beautiful. So now all we need to do is just make sure that we finish off this normal code and make sure that's right. So I want to reconstruct a normal in view space. So from world, so hit position, you need to reconstruct the hit position in, let's hit view space, hit position, world space. So that is, how do we do that again? Views. Oh yeah, obviously it's ray origin, world space multiply, sorry, add. Multiply, scale, redirection. Wait, no. So we've got one in local space. We translate that from local space into... So I think you need the inverse. You need the bog standard. So you rotate it first, this time into world from local, hit dot position, so that's in local space. Then we need to add on center position, and that'll bring it to world space. And then we need to do just another rotation on the normal. Hit normal. So then we just need to do a hit position world space, hit normal world space, and then get the view space version. And then with the view space versions, I'm missing a T. So we get a T but in a length of view space with ray origin view space. So that'll just be a length of that. T in view space. View space. Okay, so that should be everything reconstructed properly. Oh, what crap is this doing? Global. Right, so that should be the debug draw code working for this weird outlined ellipsoid. So now we should be able to build this outline ellipsoid in shader code and debug our tree. Our BVH tree. Hello, what is the game going to be about? Do you know yet? Yes, I've got a document, a design document. It's going to be an RPG. I haven't really gone into the exact details of it yet. But yeah, it's going to be like a top-down, probably somewhat of a fixed camera looking down, but it might move around a bit. But yeah, RPG top-down. We shouldn't really need an LOD system, I don't think. And yeah, it's probably going to be a bit until we get to actually making the game. But then the graphics, finding the art style right now. After we've got the basic primitives rendering, we've had basic primitives rendering a few times, but I've been trying to find a good way to do it. I'm just settling on doing a bound and volume hierarchy. But after this, we're probably going to put rendering on a pause and go and do some more engine-y / editor work. So we do some like engine stuff, like working on multi-threading the engine because we're going to need it. And I'm going to write more code, and I don't have to change a whole bunch of code when I make the engine multi-threaded. And after we put that system in, we'll probably build a simple editor, which will allow us to edit and construct models out of ellipsoids. So we're just trying to get the ellipsoid renderer working, which is it's got PBR. This is some segment of an ellipsoid we're seeing, but it's obviously not rendering right, and we're trying to fix that problem. But yeah, we put PBR in. We're just trying to debug that all now. And then after we've probably got an editor in where we can start putting stuff down, we might go back to rendering and finish that off and make it look awesome. Or I might just start prototyping some of the game out. So that's probably the roadmap for, and I won't probably reveal the game idea until then. The game idea is in the repo though, for those who are supporting me, there is a document, if you want to read it, is in here. This is the outline for the game. Yeah. So if you want to read it and send a message, have a chat with me about it, that's cool. It is there to view for people who are supporting the channel. But yeah, I'm also not 100% set on that idea. It's that idea that I really want to do, but I'm also open to thinking about it a bit and changing things. So yeah, let's go ahead and so I've got a thing where I say like pack quad tree. This is the final shader that runs. This thing has all of it constructs the whole hierarchy of right. So what we'd like to do is we have all of the bells and whistles right here. So we should just be able to say draw 3D ellipsoid, center position snorm. Bear in mind we've got to multiply some of this by like 4 or something like that, because I think what we did is we of 8. Got to be a bit consistent here. World space, half dims world space, and then we've got a bit of that rotation in there as well. Rotation. Yeah, so hopefully this is the GPU version kicking off now. Yeah, that's good. So hopefully this will not crash and burn my computer. If my stream dies, we'll be right back, but it shouldn't be. I did a bit trig, and I think if you initially have a quaternion, oh, you did a bit of trigonometry, right? With a negative W, and then you just have to negate all components, and you will have a quaternion with the same rotation but positive W. Right. Oh, so you can do that before you quantize it. Then you just have to negate all the components. Excellent. Yeah, that's cool. Thank you so much. I'll keep that in mind. And if I get stuck, I'll call you on it. I don't need it necessarily just yet. Right, so here's our tree. And I'm getting a bunch of... Like, we shouldn't be seeing 4 ellipsoids. And what we should also be able to do is debug and render the... We should be able to debug render. Right, so I think what I would like to do is say if... What is it called? A lock mouse or something? Trap mouse. Yeah, so we trap mouse show it or something like that, I think. And then if we're not trapping the mouse, I think that'd be cool. Yeah, so we trap the mouse, show the tree, and then... Oh. What? That's the wrong way around, isn't it? The mouse is already trapped by default. Oh. No, something's really weird. if trap mouse show. So it should be shown by default. Mouse. Right. Yeah, the problem is in it's in this virtual mouse hide and show in main somewhere. Yeah, it should be hidden right away. I commented it out, so what state is it starting in? Right, okay, so I want to make that true. Oh, wait a minute. There's a rose in it. I guess it's not trap. Yeah, that's correct. So trap means I want it to go around the world and yeah. And not trap inside the window. Yeah, okay, this is what I want. Right, so we're gonna need to see the tree here. So if I turn the tree down, we'll have less nodes, right? So you've only got 4 nodes. I'm not seeing the most parent one. So these are the 4 nodes we should be seeing being rendered. And also, why is it everything so I'm not seeing it like a hollow. I'm not seeing like a hollow looking thing for some reason. So I'm putting this border thickness unorm in. I'm not seeing that. That's going in as 11. It's 100% the same. So why is this one on CPU side? Why is this one on CPU side? Why am I seeing it like this one here, the one that's rotating, like hollowy? Things. Let's make it 001. And we're still seeing them, that's very strange. So at 11. And we're poking it in at 11. So float 32. Let's poke in 0.1 and see what happens. Oh, they're not even showing up anymore. Oh, it's a double. Crap. Yeah, so doubles when they're constants and get converted. I think they're a bit problematic in my compiler. For crying out loud, it was that. I need to write it down and fix that. We should just stop. We should not. Yeah, so what's problematic is so doubles so constant time casting. So compile time casting. To float is incorrect. We should error on this. Yeah. Alright. I'll do that one soon, I guess, because it is kind of a pain. It does affect me a bit. Right, that's good. So I think as well, when we look at 0.1, hey Crimson Mania, how you doing? Yeah, I think I've got a thing to sort these dimensions. And we should probably do different colors based on their depth in the tree. I don't know if we can do that, but we'll figure it out. But there's a thing where we can do. I was thinking when we do that Rayverse ellipsoid outline. I had a version where. Oh, what did I do? I did the inverse. We divide thickness and radius, I think. And then we need to. So this will mean that the thickness of that outline, it should scale to the kind of how big the radius is on a certain dimension. So we shouldn't get. So it shouldn't be so thick if it is so wide. Yeah, so we get some more thinner looking things. Is it really good? See, these are quite thin now. And because this X1 is big. Yeah, I might leave it alone actually. Let's undo that. Like a bunch of spaghetti. Right, so let's bring it back to something simple. So in this drawer, debug drawer of the ellipsoid, we're doing it when we construct the tree from the bottom up. So we start the leaf nodes and we traverse up the tree. And we do this. Yeah. Maybe it's okay if we just do the one, so won't be doing the parent. So if we're bringing this down to these number of nodes, so we've got 4 nodes. I should get rid of that debug drawer. That shouldn't be the spinning one. Don't need you anymore. You've served your purpose. Doing good. How am I doing? Doing good, my friend. Yeah, just been chilling out basically. Just relaxing. Keeping things yeah, just try and relax over the weekend, you know. Problem is I can't tell anything what's going on right now because there's too many nodes. So you should have 4 children, and then the parent won't show because it's the root node. Maybe we'll just start with that. Just or draw the root node as a different color or something. Yeah, been quite busy. So also in the UK, when it's summer, everyone does something on a weekend because it's summer, you know, tons of stuff going on. So it's good when you get one of those weekends which is kind of relaxing. It's been very nice. So I think we would like to. So this is saying while it's not the root node. So we would like to say maybe get all of this here and just construct just do it again, you know. Just extract all those things. So is it doing it right? So build node would then be the root node. That should. And gets the number of children, visits the children, and then constructs a node from there. Excellent. Yes. So we should be able to tell. Shoot. Yeah, we need color. We need to color them, but maybe we don't need to. Right. So this is the parent one, the biggest one that's going across here. Oh yeah, we should color it though, just so we can all see it. Give it a different color. Alright, that green one is the root one. So obviously it's not actually going around the edges of these ellipsoids, and it needs to do such thing. Right, so this needs to come up a bit higher and all sorts. So the way I'm constructing so this is the problem, right? The parent node here is not surrounding the children nodes. And so obviously when you ray trace against this parent one, here, you should hit against this one, this parent node here, because one of these children is this guy, and we'll just get a clipped ellipsoid at this point. But it gets even worse because these children often have... Oh yeah, this gets really bad. There's something else that's going on. Probably the ray tracing code. How am I calculating the size? Well, it's with Henry maths, so it's obviously wrong. We'll figure it out though. So I think so I visit all the child ellipsoids, I deconstruct their center position, rotation, and all that. Maybe what we should also do is just see if they deconstruct properly, right? That's another thing that's interesting, right? What happens? Are they being deconstructed properly? And we'll do it with a slightly different color. If they draw in the same place, then awesome. If not, then problemo. I was in Norway for the last 4 days. Cool. Why did you go there? Was it for a conference or something? I think that's alright. Wait, where's the rotation? Right. So first of all is the... Right. First problem. So the red ones are the ones that we're looking at. And those are wrong. They're not resembling... So dequantization is either the quantization is wrong or the dequantization is wrong. So the red ones should be exactly where the other ones should be. But we are actually getting valid data because they kind of look the same. So what you could say... Right, so this one's pretty close, right? This is another one that's pretty close. I can't really tell what's going on. But these two are clearly wrong. Should we disable the other ones and see how close this, like what shape that is? I think it's... Can't quite see it, the rendering is quite weird. So let's just see the root node. Yes, that shape of that is actually quite similar as well. So these two are actually quite similar. These two are a bit off. Well, no, really off. So there's something up with the one of the components. It could be along this axis. No, it's along two axes, isn't it? It's a bit weird. But yeah, so it's safe to say that the dims probably translates okay, like the half dims. We're expecting them to be a little bit off because they get quantized, I think. Yeah, we're expecting them to be a little bit off, but they shouldn't be massively off. So let's start there. Snorm, unorm. So it's center position. Right. So let's open up another screen. And let's move it. Right, so this is where we do the initialization. So we're getting it. It's sine norm, -1 and 1. Turn it to 0 to 1, so u norm. Then this one, they have different... Right, the y doesn't have the same level of precision. So this could be the reason why, is the precision of the y. It could just be that bad. So if we're reconstructing it every frame, why don't we have a bit of a play? We should be able to add to every one of them a bit of y and just see how it behaves. Where's the code that does that? Here, center positions. Here we go. So we should just be able to say it will be a bit of a problem when it goes out of bounds though. But let's have a bit of a play, let's say. Plus sign time in seconds. Scale by 0.1. So that should, if we see it sort of jumping, then I think that's a big issue. Right, so we're not seeing it jump. Let's do this. Right, so they're slowly moving, but they do... They do jump, which is a bit weird. There are some key commands where I could cycle through the layers. No. No, I'm just, when I built the tree, I just draw everything. I don't really have any debug visualization stuff yet. This is the first round of it. I don't know if I'm keeping. Yeah, I'm not sure. I don't think I'll keep this, to be honest. Yeah. They could be jumping around 0, maybe. But then why aren't the other ones jumping? Oh, they are, right? No, this ain't jumping. Neither is that one. We could add a little bit more. Haven't hit the boundary, maybe. Yeah, maybe they could have gone out between 0 and 1. Yeah, maybe they've hit the bounds. Oh, that's a good point. I should draw the bounds of the area. Like, what is -1 or 1? Because I could draw that as a bounding box. Where are we going with that one? So it would be nice to draw 3D. So -1 to 1 is actually. So AABB will be in view space. So on an OBB. So I put in view from global. Damn audio. Alright, should be back there. And then a bit as well. Yes, that's a good point. View from world. So what do we need to put in the rest of them again? I forget. Is it offset and half dims? So the half dims is going to be 8. Yeah, so I've multiplied my normalized space by 8. Wait a minute. So if I'm multiplying these by 8 and one of them is unorm, the other one is half dims. Like unorm and sine norm, I meant. Right, we'll draw the region just for a second, but I think we should actually think about that, because I think it could be wrong. And then it's probably the color, and then do you want to Z test it? Oh yeah, it's here. Whoops. There's a border thickness, so we'll chuck infinity in there. Alright, so where's the bounds? I don't see a bounds anywhere. Oh, maybe we do a bit of a 0.1. Oh, it's in there. I see the cube. Yeah, whoops. Okay, so maybe, just maybe. Yeah, so this box, I don't know what, this box is probably in the wrong place to be honest, but right, so we put everything back to something sensible. So the half dims is 0.5 of the box. I think that's right. So we just did a norm version. And then we just did, let's remove all this scaling crap. Because I think that could be messing some of it, the visualization stuff up. But yeah, we can always undo if we see a similar thing. What else we debug drawing? Oh no, that's scaling by in the... Right, so it's going to be really tiny now. But it's cool because we can still look at it. Right, so this does look a bit different, doesn't it? Yeah, so it keeps... someone else feels off. Yeah, it does look like the box is a bit in the wrong place still, doesn't it? I don't know why. I don't know what's up with my box. It should be centered the way it works. Let's draw another. Let's fix it with more drawings. Let's put a sphere in there in wild space and we'll drop it in the middle with a radius of 0.5. So if a sphere fills the box, then it's in the right place and someone else is wrong. Right, the sphere is in the middle. So the sphere is in the middle. And I'm passing a radius of 0.5. Yeah, the nodes are maybe in the wrong place. I don't know what's going on. But why, also what is a bit strange to me is a sphere of a radius of 1 is going to be the size of that box. Still, that's wrong. Is that right? So an OBB, that's where I tested this before. Yeah, it's signed norms, so -1 to 1, so it's got a length of 2. Yeah, that's correct. Okay. -1 or 1. Yeah, that's fine. Okay. Alright, we're good. So these are okay. The issue is the What are we doing here? So we can print it out. Figure out what's going on there. So looking at the printed values, they look pretty in range to me. Am I rendering them in an odd way? We can try and bring back that code I had before. Well, no, I guess we can't. Let's drop an... You always fix it, one more ellipsoid. Let's put another one in. We'll make it unit length, right? 1. No rotation. Bit of quad. And let's make it... Guess we just make it white or something. So it should have an ellipsoid which covers the like a unit ellipsoid. The sphere then. It does look like it's covering it. Right, so the center positions are in the right place, but the half dims are probably outside. So the half dims make it go outside the box. But why? That's a lie. Or is it? It's so damn small I can't see it. Is that one all the way to the left? Can't see it printed out that way. Why is that one all the way to the right there? Okay, so I think that the rendering code is fine. Did I not change all of them quickly? Did I not do that? I'm not scaling any of them anymore. Oh, one thing I did not try and do is actually change any of this code. Like I didn't try and test the offset code. Okay, was not wise of me. So say if we did 0.5 and then if we offset, so it's got a 1 diameter. So that should be to the right hand side of the object. That one. Is that true? And it... That didn't appear to move, did it? It just shrunk. Let's up this so we see a fillet filled in ellipsoid. If I put that back to 0, where does it lie? Why didn't it move, did it? So maybe let's put it at 1, see what happens. Oh, sorry, it did move. It moved on the Z. Or what we think is the Z. So that moved... Yeah, I think that's alright. Because it moved here to the edge of the box. That's 1, yeah. Alright. So we did like 111. It should be on the corner of the box. Oh, we're only printing the root node. Whoops. We should be printing these guys. So these ones are probably out of bounds. That's why I was only seeing one thing being printed. Right. So I think the ellipsoid rendering code is fine as well. Right. We're seeing values outside. See, they're at 2. Okay. Right. What problems? I see it now. So. Okay. So I think this is fine. So when we take it out, we're getting values that simply go beyond the possible range. So what are we doing? So we produce the. So I don't think the snapping is not the resolution of the value now. So I think where we pack in them is not working. So Z as a 0, X. So they're both they're all at the start. Yeah, that's fine. It's just, are they? So Z gets 15 bits. Oh, did I do my bit pattern wrong? Yeah, I did my thing wrong. Damn it, why is this thing... Okay, good. E. Yeah, E's the wrong one. Damn it. I want 7. Why? My life. I thought I was a wizard. Clearly not. So yeah, I got that bit pattern wrong. No. So that could... That's part of the... Let's double check them all right. So that was Z. Y, 12 bits. Oh, 1, 2 is not the same in hex, is it? Yeah, but... Yeah, what am I doing here? That was 10 bits. For some reason, I didn't do that properly. Oh, damn it, I'm all over the place with this. I got the 16-bit one right. That's good. Give me a medal. Right, okay. So clearly we probably got some copy-paste problems here with the half dims. So what do we do here? So the half dims are 15. That's another 15 bits. So that's a 7 again. Whoopsie. This one is another 10 bits, right? 100? 10 bits. Well, that's 10 bits. Okay, that's fine. Then is the Z 4 bits. 24 bits. 4, 8. Oh no, so it's 14 bits. 4, 8, 12, and 2 more bits. That's alright, isn't it? So that'd be... Take 1. Yeah, 3 FFF. Neat. Okay, I think that's the quantization fixed. Just give it a go. So those red and white ones should all be lined up now, or those children red and whites. Right, this is looking better. There we go, we're getting the Z fine. So they're all overlapping, which is awesome. But obviously when they reach the edge, of the box, problems happen, right? So I think to remember as well is So they won't actually go outside the box. We're going to stop this in the editor. So in the editor, we're going to prevent positions going outside the box. And we already have with the random number generator. I've just made it move so we can see it in action and hopefully catch some of the problems. So this is looking good. The only problem is the so we're able to reconstruct the position and the half direction perfectly fine. Obviously, if it goes outside the box, we can't. So my next concern is like if the half dims push the ellipsoid outside the box, is that a problem? Realistically speaking, it should fit inside the box, but the root node, like, I don't have a root node, but maybe I could store the ellipsoid which fits around the object. Maybe I could store the ellipsoid which fits around the 4 final nodes or whatever, or the 4 children of the root node, and store that somewhere. So when it goes in a top level BVH, it could be correct. Oh no, because the top level BVH, when that one gets constructed, it will look... It could look at the children and construct a BVH for that. Yeah, so I'm not too concerned with them going outside, actually. Maybe. They might be able to go outside the -1 to 1. As long as their center position is within there. That might be possible. We'll try and keep that. That'd be interesting, actually. We'll see if that's possible. But this is good. I like where we're at. So now we've got to fix this root node here, which is the green one, 0. Its children are not being correctly calculated. Like it should be fitting around the children. So we're going to look at that. So we're going to remove the animatiness. Right, I just want to take a quick break. But we're back in a couple of minutes. And when we get back, we're going to look at this code here, which calculates like the most furthest point on that ellipsoid and how we construct the parent ellipsoid from the children. We'll see how to fix that in 2 seconds, BRB. Right, welcome back everybody. So yeah, before I forget these tricks with these quaternions, I want to quickly just write the code in there at least, and we can test it later. So the packing like this, there's a bit of a trick. So there's a trick to say if rotation.w is negative, then negate all the other ones, and then it'll produce the same. It produced the same rotation. Wait, what did Glorious say? All components in your silver quaternion were the same, but positive. Right. So negate everything. So return negated. Oh, what did I do there? ZW. And then quantize just the XYZ, keep those, but discard the W. So I don't need to negate the W anymore. And then when we reconstruct it here, it is the square of this, because we tested this, right? The square of that, square of this, take all of that, and then square root the whole thing, and that'll get you W. That's it. Reconstruction. Oh yeah. Right, so glad I won't forget that. Right, so where was we before? Yeah, so I want to figure out how do we build a bigger ellipsoid from a bunch of smaller ellipsoids. Yeah, how do we get the outer ellipsoid? So the technique I'm kind of going with right now, which is failing, is I go over all the children, I keep the min-max, right? Min is set to max value, max is set to min value. And the idea is we're trying to find, so I get the center position of the ellipsoid. I apply some rotation to the half dims. Doesn't that change the... Oh yeah, you probably want to do that, I think. So what it would be in... So you've got it in... Your half dims are in local space. B, you want to move it into world space or something like this. Is that even true? Yeah, I think this... But anyway, this won't be applying to any of them because we've not got rotation on. This is going to cause a bit of a problem, I think. We should think about it first. Well... Yeah, then we sub the offset and then we add the offset. Yeah, but that always won't be the min and that always won't be the max. I think that's the problem. So you want to get two n's and min both of them. So I think you want to produce... Wait. Because... Or you get the ABS of that and then you can just... And then you can do it once. So that will get you a... I think so. But still, we would that wouldn't change anything because we haven't got any rotation yet going on. Um, hmm. Yeah, I don't think that would have changed anything. We take a look at the output. Yeah, it still doesn't surround the objects. So let's try and draw it up and see what we're trying to do, right? So the basic idea is you have an ellipsoid like this, and you have another ellipsoid like that. You've got a center position, you got half dim, center position and a half dim. And what we want to try and construct is something like this. Damn it. Something like that. And a half dim, right? So the idea is I take this point, I get this half dim, and I compute that point. And I compute that point. I compute that point, and I compute that point. So the idea is you compute a min-max. So like that. You got a min, and you got a max. If you know, you can get the half dimensions of that, and that's your... then you can start from min and add the half, and you get this center position. But seems good on... I don't know, my drawings are a bit off. But that's the basic idea of what we're doing. But I think it needs to add a little bit more because it's an ellipsoid. It's not bounding box. There's people screaming right now. Imagine they're watching the football and something good or bad just happened. So what is going on? Is it a good idea? Min max. I think this is, working fine because take the min of max of those, yes. Subtract, get half, add. Seems fine to me. So I think just the way we're doing it is wrong. Um, so we could treat it like circles and then just do it in multiple dimensions and it could translate well. But you want to get like an... Thing is, I need a better drawing tool. Maybe I could try Krita for this one. Right, that's elliptical. Huh? Yeah, it's got an ellipse tool. Right, sorry, I did the wrong thing. So let's try it here. So you want to produce, so if you have that, should we start with spheres maybe? So to produce the outer sphere, do it smaller. Too damn thick. Things I never like about these tools is it doesn't center it. You know, I know where the center is. Here we go. Well, I didn't know where the center was, but it's easier to guess with the center. Perfect. Right, so wherever I just drew that center, I don't know, somewhere about here. So, you know, as you would think, it's the center position of this. Where's the brush? Center position of that. So we did plus the radius. You wouldn't get it, right? You would get down here. Or plus or minus the radius, you would get it up here. Get a different color because it ain't working. Yeah, I can see where the formula falls apart already with the circle, right? So if I did plus the radius in x, y dimensions, you'll get up here. And then negative, you'll get here. Same with this one, so with the center position here. You'll get there, then you get there. But what you're not getting is it's not really the, you know, it's radius, isn't it? So I think what you want to do is you want to, is it square root? Hey, what is it again? I forgot the idea. So you do a, right, yeah, that's so you do plus on each axis rather than a multiply. Is that right? What am I doing? It's half dims. Of. Yeah, but it's an ellipsoid, isn't it? So half dims for a bounding box would get me there like that. But because it's an ellipsoid, it works this way. So I need to make the ellipsoid big enough. What am I trying to do? Hmm. Yeah, and this is actually a very poor example. I should... let's redo it quick. So we'll do it again, but with... Just get the red. What crap happened here? So let's just go to ellipsoids now, because I think we didn't. It'd be kind of poor if we didn't do ellipsoids. And we want the outer ellipsoid of this. So let's see if we can get it. Right, a bit off. Oh boy, it's way off. That's alright. I guess, is there multiple versions? Maybe that's part of the issue, isn't it? You don't know. So how am I going to reconstruct? Something like that, you know? I guess that's a good idea. How am I going to reconstruct that? Let's get the brush. Yeah, so that's what we're going to try and reconstruct. That outer one from two ellipsoids. So I can't simply just... So you could maybe get the 4 straight points here, if you will. Then you probably get... That's not really going to help, is it? So you want... Yeah, getting these things... Well, getting those is the equivalent of just getting the diagonal like I was doing before, I think, anyway. You get the min and max diagonal. Yeah, it's very similar. Getting the 4 points, maybe. Yeah, the min and max diagonal probably isn't enough. You need to get all of the different corners. Maybe you do need to get the diagonals like that. Then if you're taking that as a point and saying like, oh, you know, now make an ellipsoid from that, well, that's the half dims for it. It's still a bit off, I think. It's still a bit off because this reaches yeah, so maybe it is get all the axis aligned points. If you take all the axis aligned points, such a min x. So it might go as far as out to there or something. Right? Or even further, like down a bit. Yeah, I think that's what we need to do is get all the axis line points. But in 3D there's 2 more, isn't there? Because you got front and back as well. So you got 6 of them. But yeah, we're doing this at build time. Yeah, let's give this a go. So what you want to produce is 6 points. And you know that 3 of them are going to be max and 3 of them are going to be min, I think. So and when it comes to rotation, let's just quickly finish this off with the rotation aspect of it. With the rotation, you've rotated this half dim, which was that, into that. I think what you would need to do for it to be effective. So we've got the, will we get these instead? Is you would lose the, what is it? You'd lose the, you would take the max of this and that and produce a vector like that. And then that will be used to produce an ellipsoid. That's a little bit maybe wider in this case, such that it would handle this case. But will it? I don't know, because it'll kind of maybe cut in. It's hard with this silly drawing I just did, not gonna lie. Wait, see if we can think about this now because we're writing the code for it. So with the ellipsoid tool, you can get a bit of a rotation. That's interesting. Is it interesting? Is it like an edge? Oh, it's like a rotator one. I've changed the pivot point in it. Ah, I got a rotated one. Excellent. So say if we rotated it like that. So you'd then... So with the same logic, would you get these points instead? And then produce a min-max for all the points, because this is now outside, so your left and down is there, but this goes further down, right? So that wouldn't work. So maybe you would produce the maximum. So you got a vector which goes, which represents the half dimensions, and for this old one, this pink one, then the rotated one is a vector that's here. So if you rotate your thing from local space into world space, you'll get this world space directional thing. Well, it's not in, it's kind of in local space anyway, isn't it? Yeah, I forget these things. But anyway, you take the maximum of those two vectors, so you produce a vector which is more right. Then this is the one that you construct at the top. Well, you're not getting that, is it, with this half dim? I just remembered. Oh no, you are. You're getting one up there, isn't it? Oh no, it's a radius. Yeah, radius X, radius Y. Yeah, so it'd actually be up here. Whoops. Produce that a bit better. That should be up there. This one will then be sort of over here like that. So then you'll produce one that's kind of more that way. So then you'll produce one up here, a point down there like that, point to the right over here like here, and a point over here like there or something. So then when you produce your min-max, you'll get a value down there. So it'll be a bit wide. It will be much bigger, and it won't be perfectly snug, but it'll be correct. So then your ellipsoid will be like that. It's more of an outer bounding ellipsoid of, yeah, which encompasses, it's an axis line ellipsoid which encompasses the rotated one. Okay, that was a bit confusing, but I think we got it. So to handle the rotated one, we need to translate the points. So translate a new offset, and make a new offset. Okay. Rotated dims, half dims, and then you just want to get half dims, which would then be the max of rotate half dims and whatever the local space half dims were. So that would then mean you produce your 6 points. Near far. Wait, is that the same thing though? Yeah, but doing near far and all that is the same as just in the corners. What have I thought? What's different? Because getting each of these points was the same as this corner one anyway, I think. Yeah. Okay, maybe I thought about it wrong. Shoot. So on paper this seems to make... Right, let's not do the rotated one anymore because we've solved the rotation problems. Let's just go back to basics. What is different from getting the diagonal and just reflecting it? That should be fine. But that's not working. Anyway, we'll run this. We call it offset. We'll run this and see if it's changed, but I don't think it's changed because I think it's a unit quaternion anyway. Sorry, identity quaternion. Anyway, so I don't think it would have. Oh. Why is that tree looking different? Right, so get out of there. Right, I think we're encompassing... Oh, it's the same thing. Yeah, it's not changed. Camera's so small because they're so... Sorry, it is so small so the camera's so fast. But that green one is not encompassing these guys yet. So we could target each of them and draw these said points. So what we can do is shrink their... If we shrink these things so they're a little bit skinnier, let's half it. And what we can do is draw the points and just see what their... So we can draw their mins and draw their maxes. So draw 3D sphere in world space. I want to draw min. Right, I want to draw it with a 0.1 width or something like that. I don't know, radius. With like a -1 color, so whites, I guess. Maybe we can do something a little bit different. Yep, that's fine. And then I could do the same for a max as well. So we can draw a min max on as well. See how those look. Right, so you got these. Yeah, so these spheres are going outside. Yeah, this camera's way too fast. I need to make it slower. Where's the camera controls view from world? Speed. That seems like a good variable. Make it 10 times slower. Um, still way too fast. Oh, is that the look speed? Wait, no. Ain't the look speed. 100 times slower. Alright, that's better. Yeah. Alright, let's make it 3 times as fast as that. Alright, so we're taking a look around here. This pink is obviously the min, and it's lining up with the, I don't know, let's call that the x-axis, and it's lining up with the z-axis there, right? So I think the min and maxes are in the right places of things. It's just, obviously we're not giving it enough. We need to make this number bigger somehow. So I think so if the half dim is between 0 and 1, what can we do? So I've already got a point here. Oh, well, sorry, we've not got a point there. Yeah, we need a point that represents over here. That's what we need if we want to get an ellipsoid like this. But yeah, you want... Yeah, I know. Maybe we can Google for the problem. Outer ellipsoid. Should just translate to 3D, right? Ellipse. That's intersection as in calculate overlapping between two ellipses. Yeah, that's not what we want. That's like the... Oh, interesting. That's an interesting observation there, isn't it? Right, I've seen the discussion on here about enclosing points in an ellipsoid, but is there an algorithm to enclose a set of ellipsoids one ellipsoid? Huh? Here's a hint. What is the smallest set of points that you could compute from each of the ellipsoids so that a single ellipsoid containing those points would contain every point on the ellipse? Right. Interesting. It's pretty clever. It's a different way of thinking about it. There's one with an ellipsoid as a paper. 404 not found. Lol. Great. Internet's falling apart. Bounding ellipses. So I just need the top and bottom. Sorry, the same diagonal thing that I have, I think. Hmm. Um. Pretty cool. But yeah, I guess that's another way of saying it. You know, calculating a bounding ellipse. It's not bounding box ellipse, though, on bounding ellipse. Given your ellipse has the same aspect ratios, you can work out the basis. Mm. Right. Right, what does that get you? That's sweeping the whole ellipse. It's pretty insane. I guess you could step it though, but still. So we want to keep our axis aligned as well. How do you calculate the bounding box? Bounding box and axis line ellipse. That's easy, isn't it? That's not what we want. Oh, and an axis line intersection line. Right. Anyway, let's go back to this one. This looks maybe promising. So looking for minimum volume enclosing ellipsoid, or your 2D case minimum area. This optimization is convex and can be solved efficiently. Check out MATLAB code and a link included. The implementation is trivial and doesn't require anything more complex than a matrix inversion. Great. Anyone interested, through this document below. Right, so dimension of the points. Right, so we also want 3D. Number of points. Add a row of ones to the 2 times n, number of points. Matrix, so Q is 3 times n now, okay. Initialize. Find maximum value location. Yeah, it looks a little bit. Sure if I understand this too well. Right, I think I might put a pin in it here and do some research on what is the best way to find a bounding ellipsoid. We could probably hack it a bit and basically just multiply it by some factor or something. But we should probably try and get it exact because that's going to help with performance. But yeah, I'll do some research on that off stream and see where I get to. But at least today we managed to figure out or build at least a way of calculating, a way of displaying these sort of more hollow ellipsoids so we can see through and debug what's going on. So we just got to somehow produce a proper bounding ellipsoid from a set of ellipsoids. And then we've got that working. It should just be debugging the ray traversal code, because the tree should be constructing properly when you get one of the layers working, the rest of the layers will just start working. So that'd be cool. So I want to try and find someone to raid now. But I'll next be on Tuesday at 7:30 p.m. GMT +1. But yeah, there's a Discord if you want to come and hang out in the meantime. Until then. Following. Eric's just playing Magic. Fair play. Can't sort by tags? What's going on here? Oh my days, people are funny. AI Trump versus AI Biden. Amazing. Probably couldn't be much worse than the real thing, eh? I'm getting back here. Right, thank you for coming, everyone. I'll see you all in the next one. Have a good start to your work week. And yeah, catch you all later. Bye-bye. Bing.